Example 4, find an equation of a tangent line to the graph of f of x equals x squared when x equals -2. Okay, typically on a test, I'm not going to give you the graph. I'm going to have you actually come up with the graph on your own. But I think most people can graph this function here in red. Okay, and then this is what we're going to find. This blue line is the equation of the tangent line, okay, when x is -2. Okay, so we're looking at that intersection point there. So let's illustrate this using calculus. So first of all, we're going to take the derivative of f of x, which by the power rule would be 2x. Then we're going to find the slope of the tangent line, which is the derivative of this function when x is -2. So this would be 2 times -2, which would be -4. So now we have the slope. Okay. Now we're going to find the equation of the tangent line. So we know x is -2, and then if we want to find the corresponding y value, we could plug that into f of x, which would be 4. So now we have an ordered pair at -2, 4. So now it should be fairly easy for us to come up with the equation of the line, which will be represented as y equals mx plus b. So y for this problem is going to be 4. M for this problem is going to be -4. X is going to be -2 plus b. Now we'll solve for b. This is going to be +8. We're going to subtract 8 from both sides. I'm going to get -4 equals b. And so now I can use my slope and I can use my y-intercept to come up with the equation of the line, which would be y equals -4x minus 4. Let's look at the next problem. The next rule we're going to look at is the constant multiple rule. So this says the derivative of c, which is a constant, times f of x with respect to x is the constant times the derivative of that function. So let me give you a concrete example to show you what I'm talking about here. Let's look at A. Okay, this would be a constant times a function x cubed. Okay, so when we want to take the derivative, what we do, we first of all figure out the derivative of x cubed. Well, we know the derivative of x cubed would be 3x squared, and then you multiply that by the constant. So this would end up being 15x squared. Typically what I do, if I have a problem that satisfies this rule, when I find the derivative, I just take the exponent, multiply it by the leading coefficient, which gives me 15, and then I subtract 1 from here. So I just do it that way. Okay, let's do some of these. These are quick, so we can get through a lot of these. Part B, a lot of times, the trick for these problems is to rewrite the problem. So I'm going to rewrite this problem as y equals 2 times x to the -1st. That's the same thing. Now I'm going to take the derivative I'm going to take negative 1, multiply it by the 2, which would give me negative 2. And then it would be x to the negative second, because you're going to subtract 1 from that negative 2. That's the power rule. Okay, let's look at C. So for this one, when we take the derivative, so f prime of t, you're going to take the 2, multiply it by 4/5, so that's going to give me 8/5 t to the first power, which you don't need to write the first power there. Part D, we've got y equals 2 times the square root of x. I'm going to rewrite this as y equals 2 times the square root, 2 times the square root of x, 2 times x to the 1/2 power. Okay, so we're going to write it this way first of all. Then we can take the derivative. So I'm going to take 1/2, multiply it by 2. That would give me 1. And then it would be x. And then I'm going to take 1/2 and I'm going to subtract 1 from 1/2, which would be negative 1/2. You could leave your answer this way or that way. Either way would be fine. Alright, let's look at E. Again, the first thing I'm going to do, I'm going to rewrite this problem as 1/2 x to the negative 2/3 power. So first of all, I'd rewrite it that way. Now I will differentiate. So y prime, you're going to take the exponent, multiply it by the leading coefficient. So I'll just write this out. Negative 2/3 times 1/2 times x, and then you're going to subtract 1 from this, so this would be negative 5/3. Then to simplify this a little bit, these 2's are going to cancel out, so this would end up being negative 1/3 x to the negative 5/3 power. Okay, finally f, y to the negative 3/2 x. So when you take the derivative, the exponent is 1, so this would be 3/2 x, and then when you subtract 1 from 1, that's going to be 0. So you wouldn't want to leave the answer this way, because we know x to the 0 power is 1, so my answer would be negative 3/2.